Hello everyone, let's start our subject data mining and warehousing. I'll give you an overview about the subject. Before that, I will tell you how I am arranging the slides. I will give you materials as day 1, day 2, etc. And for each and every material, we will have different sessions. Day 1, session 1, day 1, session 2, like that, so that you can systematically arrange your materials in a folder, and it will be helpful for you to understand the concepts in a better way. So you may feel that it is somewhat different from the order you are seeing in the syllabus, but it's not a problem. You just follow this method. It will be good for you. Okay, let's start our subject. Actually, data mining and data warehousing are two different subjects, but due to the relevance and it is related ones, so we are studying it together. Before going to the definitions of data mining and warehousing, let us see what are the evolution of database technology. Okay, this figure shows the evolution of database technology. After the invention of computers, we need to store a large amount of data inside the computers in the form of databases or in the form of files. We were calling it as file processing systems. But in 1970s, we have identified that there are some disadvantages of using file processing systems. So a new software package has been developed, that is DBMS. Which stands for Database Management Systems. It is used for creating and managing the data in a more efficient manner. Still, many of the organizations are using this system for the effective handling of their data. But in mid-1980s, we have developed some other languages called object-oriented languages for the need for storing complex data or very large amount of data has become popular. So for that we have developed advanced database management systems. For example, object-oriented database or a deductive database, active database, etc. But the need for analyzing the data has become popular by 1980 because of the competitive pressure among the organizations. So we have developed data warehousing and data mining. But the large amount of data is being collected and used, which are normally called web-based databases. For handling those very large amount of data, we have developed big data technology and all. And the future and the present situation is we have new generation of integrated data and information systems. For example, we can say data science, which is an interdisciplinary area which incorporate advanced database technology as well as machine learning, artificial intelligence, neural networks, etc. So this is the current and the future of the database technology. Okay, we will see what is a data warehouse. Actually, data warehouse is a database which is used for reporting and analysis. So we will see this figure, then you will get an idea about a data warehouse. We are collecting data from various sources. It can be from operational system, ERP, that is Enterprise Resource Planning, CRM, that is Customer Relationship Management, or we can collect it from flat files. We are collecting all this data from various sources, and before loading into the data warehouse, we have to do some pre-process on that. That is called as ETL. That is, we have to extract the necessary data from all different sources. Then we have to transform it into the format that is suitable for the data warehouse. And finally, we are loading the data into the data warehouse. And in the data warehouse, you can see three types of data. One is summary data, and we have raw data and also metadata. Summary data is the main attraction of the data warehouse. We are storing summary data because the analytical queries can be easily performed. so that we are storing summary data. But we are also storing the raw data, that is the actual data stored inside the data warehouse. This will help us to analyze the data in different levels of abstraction. And we have the metadata. Metadata is the data about the data warehouse. You may have studied in DBMS that database also is having metadata, data about the database. By meaning, the meaning is that the data warehouse contains such and such information and in which format it is stored. Every information regarding the data warehouse is stored in metadata. And this data warehouse is used for OLAP analysis, or it can be used for reporting, or it can be used for data mining. Data mining is the knowledge extraction process from the stored data warehouse. Okay, so these are the overall idea about the data warehouse. Let us see the definition of data warehouse. A data warehouse is a subject-oriented, integrated, time-variant and non-volatile collection of data in support of management's decision-making process. So a data warehouse is a collection of data. It is used for management's decision-making process. But it should possess some features like subject-oriented, integrated, time-variant and non-volatile. We will see what are these features. Subject-oriented means a data warehouse is built based on any subject. That is, a data warehouse can be used to analyze a particular subject area. For example, it may be based on customer or based on supplier, or we can have more than one subject, and it may be based on sales. We can know the amount of sales happened in particular country in a particular period, like that. And the data warehouse is also an integrated one that we already discussed. We are collecting data from different sources. Data warehouse integrates data from multiple data sources. It can be from relational databases, flat files, or online transaction records. Before going into loading the data into the data warehouse, we have to do some cleaning and we have to incorporate integration techniques in order to ensure the consistency. Next one is time variant. Every data warehouse is having an element of time, which means that data is stored to provide information from a historical perspective. If data warehouse is built for a particular period, for example, it can be built for a period of 5 years or 10 years, like that, and it is used as a big data storage, and it can be used for analysis purpose. So an element of time will be there along with the data warehouse. That is, every key structure in the data warehouse contains either implicitly or explicitly an element of time. Next point is non-volatile. Volatile means, you all know that volatile means their data will be lost when the power is off or when the system crashes. But a data warehouse is always a physically separate store of data transformed from the application data found in the operational environment. So it is a permanent storage. So it doesn't require transaction processing, recovery, concurrency control systems as used with the database systems. We need only two operations. First one is initial loading of data, and the second one is access of data or reading of data. This comes to the end of the definition of data warehouse. You have to mention all these points when a question arises, like what is a data warehouse or define a data warehouse. Let us see what are the difference between database and data warehouse. Okay, this table shows the difference between database and the data warehouse. I already told that data warehouse is a database, but that is used for reporting and analysis. But it doesn't mean that a database can always be a data warehouse. It can be used to create a data warehouse. A database is used for online transaction processing. and it can be used for creating data warehouses. But on the other hand, a data warehouse is used for analytical purpose, or it can be used for online analytical processing. This reads the historical data for the users for business decisions. And next point that distinguishes both these is based on the concept called normalization. In a database, the tables and joins are complex since they are normalized for relational database management systems. The normalization process reduces redundant data and saves storage space. I don't know whether you are aware that the normalization process is also having a disadvantage, that is, it degrades the query processing, or we can say that it will slow down the query process. So the normalization is not done in case of data warehouse. In data warehouse, the tables and joins are simple since they are denormalized. This is done to reduce the response time for analytical queries. And the next point is based on the modeling techniques used. Relational model techniques are used for RDBMS database design, but for data warehouse we have to use separate modeling techniques that we will discuss in later. Next point is a database is optimized for write operations. Actually, the database need frequent updates, so we have to write something into the database frequently. So it is optimized for write operations. But in the case of data warehouse, we need not write something into the data warehouse once it is built. It can be used for years. So it is optimized for read operations. And in the case of database, the performance is low for analytical queries. Actually, it is designed for online transaction processing, so the performance will be low for analytical queries. But in the case of data warehouse, the performance for analytical queries will be high. So these are the difference between database and data warehouses. Thank you.